So when I did the periodic table back in like 95, I came up with the Vicky Mole thing. I called Oakland schools. I said, give me your worst guys, man. I want to see if this is as powerful as I think. Just the folding of the table. Because the kids in Sonoma State weren't getting the ionic combinations, you know, because when you go over from this, you're going to see the calcium chloride. You need 2 chlorines for the calcium. But nobody draws the electrons on the table. If we had one here, you'd see that the Roman numerals on top, that's the number of valence electrons, but people don't even know Roman numerals anymore. The younger people, the older ones don't take that personal, but we can still read. Now it's easy with 2000, but remember the movies at the end, they'd have MCM, you know, we could go, oh, that's 1973. You know, now kids go, what's all that? Anyway, the point is, water is a magnet. You got a plus side, a minus side. The way I was saying, this is how water sticks together. Not even the sodium chloride yet. The negatives of water is going to grab onto the positive. So here I was at Oakland Tech. This poor wanted to learn. Every class, a fire alarm's going off, man. We get back and there's glue in the door. You know, I mean, these kids were just, they got tired of it. You know, it's fun. It's like, oh, a fire alarm. We get to that. After a while, they're like, oh, not again. These kids wanted to learn. So we had them in there, man. And I go, so the way water sticks together is when Mickey grabs her ear. I'll never forget that kid goes, man, what you talking about grabs her ear? Her ear. So I did this whole thing. When boys grab her ear, they get a little excited because water's vibrating, right? You got to remember, we got to have real representations of what water's like. Water in the liquid is moving, right? It's dynamic. So when he grabs her ear, he gets more excited, more excited. What does he do? He pulls her proton ear off. If I had another red one. What this does is it gives Mimi a real negative attitude. I can't do it in red because it's got to be positive. This is why it should be in green. OH minus, the hydroxide anion. Ions, anions, you've got to stay. That's what's so important about it. Hydroxide anion. So now Mimi, without her proton here, the electrons stay. This is what's fundamental again. The oxygen, electronegativity, everything we've learned right in introductory. Oxygen holds the electrons. The protons go. This is one of the only times you'll see ions created when protons go. Usually ions are electrons coming and going, right? This is the only. So Mimi, without her proton, she gets a real negative attitude. OH minus. What does she do when she bumps into Marty at the prom? After Mickey stealing her proton. She pulls the proton off Marty. Now she's H2O neutral again. So this was so cool. It was back in like 96, I guess. It was out in Vallejo, 100 degrees. In summer school, these kids were. The bell rang. They could have gone home. We still stayed. We were playing with all this stuff. They came up with Mikey Molson, bites off of Vandenberg AFB. They've got the picture of what pH is by pulling the proton off. I go back to Sonoma State and I'm tutoring pre-meds and they just won't get it because they're still doing the H3O. They're trying to memorize the way to do pH. But if you know what's happening, and this is where the balloon comes, because you've got, it's not just numbers and stuff. Now, when you're doing it and you've got the molecule, it's putting everything in different parts of the brain where they can get it. Okay. I know that was fast for the elementary teachers. I'm just, they got me on such a tangent with everything else that I was doing. The point of water is, though, that it is a magnet. So when it comes up to sodium, it pulls the sodium away with the electron staying on the chlorine. With that electromagnetic charge is what makes life possible. One electron. Because the point started was sodium's an essential element, chlorine's an essential element. One's poisonous, one's corrosive. How can they be essential? Because of one electron. Sodium without the electron, sodium ion, dissolves in water. Does water conduct electricity? Yes. I had to get somebody here. And I'm going to get somebody too, because I saw this on Jeopardy. It was so cool. Oh, it's so cool. Pure water will not conduct electricity. Again, introductory, we know this, right? Take two wire. I can't tell kids this because when you go into Southgate and stuff, you stick a plug in the outlet, strip the wires, stick it in water, run it up into two flasks filled with water. You know, put them in, they're filled with water, tip them up, run the gas, the two leads in. You're going to see them fill with gas. What are those gases? So water doesn't conduct electricity. The salts in it will. So I don't know if you did that in introductory. Do that, you know. You test.
I'll send you something you can use.
Your whole water, your Niagara, whatever that water is, all they do is a conductivity test. You don't know what ions are in there. If it conducts a lot, they go, oh, it's great mineral water. It could be lead, you know. As long as it's an ion, it's going to conduct. Pure water will not conduct electricity, was my point. So, the sodium and the chlorine, now they can be taken up by the roots. It can be carried in your blood. And one electron is what makes life possible.
Somebody has to leave right now. Can I have a table for her?
There's some. Anyway, since you've all been such a good audience, you all get laminates anyway.
Oh, great.
I'm going to try and get gas money home. But
if you can donate something to him, you can put it on. This is all he's got.
These are the most up-to-date tables of elements in the world, too.
Also come to your school. How long are you around the Bay Area?
Tuesday night, I'm leaving from San Francisco.
And I've already got him going to one of my teachers. He's going out to Perry somewhere, right?
The two community college chemistry teachers, 2IC3, have you ever heard of them? My teacher goes, oh, go out there. They're having a conference at West Valley in San Jose or something. So I set up as like a vendor. I still didn't even have my diploma yet, you know. I just started Sonoma State. So I was, you know, sitting there with the Prentice Hall and the book publishers. Boy, was that a lesson. I'm just telling you all kinds of fun stuff now.
Show him use a table. That's important.
They all come in, you know, and there's the books, the textbooks, and all that, you know, and these guys get, you know how much money these guys, Barnes & Noble's college bookstores have things in Hawaii. In February, if you try and get through it anyway, for the month, they're on vacation on the money they make from textbooks, school kids, okay? So anyway, here they are with the college teachers. And I'm there, they told me to dress down because I like never wear a suit. And I'm coming in with a suit, you know, and they're like, you're too dressed up for these guys, community college kind of teachers, right? So anyway, they all go to their conference, and I'm here, I got t-shirts, my periodic table t-shirts. I went to the bathroom, I came back, somebody thought they were samples. 8 of my t-shirts are gone. Point is, I hear this guy from Prentice Hall go over with his protege, you know, it's like, everybody's gone, you know, and it's like, this is the best textbook on the market. And the guy's like, ooh, really, really? Goes, no wonder it doesn't sell. Look at the cover. Let's tell me, man, teachers are buying college textbooks for what the looks like. So this is what I'm up against with the war of that. What was my point? So anyway, I go to San Jose, and I'm setting up with these. And I think this is what needs to be taught. Valence electrons. I'll show you right here. The middle of the gap. Have you ever noticed that gap in there? This is what confuses people. This table is designed by Glenn Seaborg. Did Glenn Seaborg know anything about chemistry? He made this easier for him and me, now that I've been studying for 20 years, because I know just about everything about the columns and the history of it. But for the beginners, this is the worst thing you can give them. This is what it took 200 years to get to this point. They can't start with it like this. They have to start with column 1, right here. Hydrogen and helium. This is what I started with. Hydrogen. I make the kids repeat after me, so at the end they know this. Hydrogen is 1 proton, 1 electron. Helium, 2 protons, 2 electrons. So, 1 proton, 1 electron, helium, 2 protons, 2 electrons. What happens when you hold a match to a helium balloon? Helium. Because, and I tell kids, this is why it's fun with me. I go, repeat after me. When you're at your freshman year of chemistry at Princeton on scholarship, and the